Gravity bar. Gravity bar. Yeah, this one.
Yeah.
Yes. So this. Can you see the picture?
Yeah.
Yes.
No,
So
maybe he came out.
yeah. So sorry for I couldn't make it on the computer. So I just made it by hand on a piece of paper. So it is a very naive explanation of how this chatbot works and what technology it uses. So first of all, a user sends a message on Messenger. Then Facebook Messenger have a very well documented dedicated API which developers like me can use to make chatbots. So that message goes to the Messenger API. After the Messenger API, now Messenger API is like Messenger API is a developer format. It only understands HTTP requests. So it will send some kind of HTTP requests to a server, which will be my server. Now a server can only understand two languages. One is Apache, and the other is Nginx. So it cannot understand Python, JavaScript, or n number of languages we have on Earth. It can only understand the server language, which is Apache and Nginx. So then in Python there is a function which we call WSGI, 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 which means Web Server Gateway Interface. So that WSGI function helps our Python application to interact with the server. So we first and the Python application can because this WSGI function is very complicated and it needs a lot of expertise to write. So Python, many good Python developers have developed many frameworks which help you implement WSGI with your Python application. So my whole code base is on Python, and it uses Django as a framework, which helps me to interact with the server. We have a lot of other frameworks like Flask, Pyramid, and Server Key. But Django is the most acceptable and most common framework. So that Python whenever the request comes, it goes to the server. Server sends it to my WSGI function. My WSGI function sends it to my Python application. Now my Python application is coded in Django. So my Django application understands what the request is trying to ask, and then it returns the response to the WSGI server. Now WSGI server sends it to the Messenger API. That Messenger API sends it to Messenger, and then Messenger sends it to the user. So that's the basic idea of the chatbot which we are trying to build. Okay, so getting back to the presentation.
I have understood fine. Okay. Well, it's not.
Present. Yes. So now understanding the key features of this chatbot. So the first one is natural language processing. Why do we need natural language processing in a chatbot? Because anyone can't talk to a machine. People like to talk to humans. People don't like talking to machines where there is always the same conversation. It gets boring. It gets monotonous. So that's why we people invented this technology, natural language processing, in which it gives you a human-like experience when you are talking to a machine. So it has because this technology is being worked by many companies like IBM, Google, Microsoft, so many companies. So I used the service which is provided by Google named Dialogflow, which helps me to integrate this artificially intelligent natural language processing functionality into my chatbot.
They recognize sentences, natural language sentence,
Yes.
dialogue, right?
Yes. So this is the key feature of natural language processing. After that, the automatic
How level are they? They are fairly accurate, or you need to change correction by yourself?
No, actually, when we give the control
Yeah.
to Dialogflow
Yeah.
or any other machine, then if you try to meddle with the human intelligence, then
Yeah.
the artificial intelligence stops, because then it can't work accordingly. So if because this is Google backed, so it's 95% of times it works,
Okay.
but maybe 5% times it
You're
can
going to
give
do
you
handle
long
something.
results.
Okay.
But it's backed by Google and it gets improved every day, so it's not a problem, because Google is doing is like the king of artificial intelligence right now. So if they have built it, it cannot be a problem to use.
So if you're going to more additional interactive conversation, you said 95% accurately they're going to recognize, and speaker is speaking out the sentences.
Yeah, because they just provide.
I understand. Yes.
In Dialogflow, they just provide you with all the database of words and
Exactly,
the
yeah,
technology,
yeah.
but you still have to configure it, teach it
Yeah, you
according
need to
to
check- you need to
your
check it, yes.
yeah, according to your purpose. Like
Yeah.
I wanted to train it for logistic purposes, so I surveyed a little bit about what questions logistic companies face, and I had to train it according to that. Because it can't happen automatically, you need some work to do also. They just give you a software. We have to organize and configure it yourself. Then this is automatic dimension detection. It is also, the whole algorithm is written in Python, and it uses a Python library known OpenCV, which is CV means computer vision. So in this, I already explained why I used a coin to get the dimensions of the box. So it also this is solely created by me. So, and it is not having any backing by big companies. So it is solely created by me. So I cannot guarantee its accuracy, because it was just me who coded it in one night. But for how much I have tested it, it worked pretty well. But sometimes it can also fail, because when the dimensions of when the box is not of when the product you are going to ship is not of a specific dimension or something, so it can sometimes fail also, because
So this idea is automatic calculating the size of box.
yes.
It's a good idea.
Yes. And I coded it in such a way.
How can you code it out for the accurate size of box?
So
How could you recognize the coin and the box size, and how did you do that?
So there is a library, OpenCV, which helps us to interact Python with the pictures, or what do we say, photos, some photos. So this whole photo, if I talk in computer terms, will be converted into a big, like let's consider this photo is of
Try to figure out the size of box.
yeah, no, this photo is of 1080 into 1080 pixels. So at each pixel, I can see there will be a different thing. So if we consider it in maths and computer science term, it will be a matrix, a very big matrix with 1080 rows and 1080 columns. And then each pixel will have their dedicated a dedicated indication of what is there on that pixel, like if it's if it's of the box, if it's of the table, if it's of the coin. So then we can process this whole matrix and see where is the coin, where is the box and where is the table. So from that, and if I can see that my in 1080 into 1080 almost 700 pixels are giving me a coin. So the size of my coin from the camera is 700 pixels, but I know the real size of the coin is 300 pixels. So I know the ratio of difference between the camera coin and the real coin. So I can just
I
see.
don't know how to calculate for the just put on the coin anywhere on the box, right?
Yes.
But depending on the user, they don't know where they placed this coin. But
So
how
that's
to-
why, as I told you, there is a matrix
Mm.
with 1080 rows, 1080 columns. If I see 1 1 means right around here in this
Mm,
photo,
mm.
right around here in the corner here. So
Mm.
this means here it will give me in the matrix, it will show me what color it is, and that, as we know, the color in, if we talk in computer terms, are from minus infinity to infinity. So we call it RGBA encoding of
Mm.
colors. Yes. So at each pixel there will be a different color. So we have in on Google, on internet, many people have researched on this, and they can tell you, if you want to detect a coin, what colors to look for. So in the whole matrix, I will look for the colors similar to coin. And even if we see the coin has many engravings. So in that engravings also will give different color. So according to that scheme of numbers, we can detect where the coin is. And then after getting the coin, we know that it all, like in the photo, it shows to be of 700 pixels. Now if I want to see the real coin is of 400 pixels. So now I know the ratio of the real and the artificial coin. So if the if the camera box is of 1000 pixels, I know the ratio of what the original box will be of size. So that's how I detect the dimension of the box.
Interesting. But how about this? Just you can calculate this front surface. But how do you consider for side?
Yeah, because that's why I asked for two photos. First first one is
Oh, okay.
horizontal, and the second is vertical.
Oh, okay.
That's why we can get 3 dimensions.
Okay. 3 dimensions. This is 3 pixels, right?
Yeah, 2 pictures
Okay, I
and 3
got it.
dimensions.
Do you understand,
So-
everybody?
Yeah, there must be some function to analyze the pixels,
Yes.
to break down the image into the pixel size, and also, as he mentioned, some color detector to recognize where is the coin, what is the box,
Yes.
and what function are you given, and what function did you to prepare by yourself?
Yeah, mostly the function to split the whole photo into the matrix of pixels is already given to me by the OpenCV library. Then
See.
I wrote the coin detection, the coin to find the ratio, to find then to find the actual size. All that was written by me.
Okay,
see.
okay. By the way, let's break 10 minutes, okay?
Okay.
And we're going to come. Very interesting. It's a good job. So which one is you going to open the information? Can you open, just skip the video, just DHS, but the other video you can show in the public? How about this?
Yeah, this I can show. I can show everything. I just
Except
have
video.
to no. I just have to remove DHL logo. I can just instead
No,
I was
this is important. This is video recording, right?
yeah, but I have the video file already, so I can just re-record the demo. I can just put now Gravity logo instead of DHL logo. And-
the thing is, I think because this is his recording, so
Yeah.
is it
Yeah.
okay? Okay, I think.
No, I can re-record, right?
I see.
So So
What do you mean re-record? No, this is already recorded.
This recording, recording this numbers.
Already this video
this
got
video.
recorded.